Jet engines are some of the most fascinating machines ever invented. This is a 3D printed jet engine designed by HPC. They power airplanes by taking in air, compressing it, mixing it with fuel, igniting it, and blasting it out the back to generate thrust. In this video, I'm 3D printing a working model of a jet engine complete with rotating parts, and I'll walk you through each component, how it works, and the entire building process. Shout out to Kativ for providing the files here, which you can find in the description below as well. Everything is well organized, and you can build one yourself today. Without further ado, let's get into building it. All the parts are connected using M3 fitting bolts and nuts. A little post-processing is needed for all the parts to remove all the burr, impurities, and the extra bits which are not needed. While I do this, let me explain all the different sections of a jet engine. I'm starting with the front fan blades. These have wide airfoil shapes designed to grab and accelerate as much air as possible. Here's the compressor rotor, where each stage squeezes the air tighter and tighter. This is the combustion section. Air and fuel mix here, and the resulting explosion powers the whole engine. Now we're moving on to the turbine blades. These have to withstand the highest temperatures in a real engine. Finally, we print the nozzle, which focuses the high-speed gas flow and creates thrust by accelerating the exhaust. The spiral painted on a jet engine's spinner makes rotation instantly visible so ground crews can see if the engine is turning and stay safe around the moving blades, while also possibly helping to scare birds away to reduce bird strike risks. The cone at a jet engine's nozzle shapes and smooths the exhaust flow to boost thrust efficiency, reduce turbulence, and keep the engine running smoothly. Meanwhile, the mixer at a jet engine's end combines hot exhaust with cooler air to cut noise and improve efficiency. This is the central shaft that holds the components in the compressor section, which is also connected to the fan blades. This is the combustion liner, which contains and directs the burning fuel air mixture, protecting the engine casing from extreme heat while ensuring stable, efficient combustion. These are the different HPC stages, which stands for high pressure compressor. And the HPC Stage 1 is the first set of rotating blades. Then the following stages correspond accordingly. In between the stages, there's our HPC stators, which are sets of fixed blades in the high-pressure compressor that redirects and straightens the airflow between rotating stages, increasing compression efficiency and preventing airflow from swirling too much. Maybe the project is not 100% 3D printed, because I will be using two sets of different size bearings so the internal mechanisms can rotate smoothly as a replica model. Moving on to the LPT stage, or low pressure turbine stage, is where hot exhaust gases spin turbine blades that extract energy to drive the fan and low pressure compressor at the front of the engine. After the assembly, let's make the base that will hold the entire display model. And we are done!